Welcome or welcome back. This is going to be part two of a two-part series looking at dial bore gauges. The first video, we were talking about our imperial setup. This time we're going to look at our metric dial bore gauge. We're going to set up and measure some cylinder liners installed to a block on a Series 50 using a metric dial bore gauge. We're going to set this thing up. We're going to look at how to read this and how to use the metric scale as opposed to the imperial scale. If you want to know more about the imperial side, go check that video out where we set up an imperial dial bore gauge to the specs for a brand new liner on this engine. We're going to use the metric equivalent of 130 millimeters. So we're going to set this to the small range, which is going to give us an indication if I've rolled an O-ring on that liner on install of a brand new liner set to 130 millimeters. Let's take a look at the table. We'll set up that dial bore gauge for you now. I have my metric dial bore gauge master gauge here, which is what I'm going to set my base spec to of 130 millimeters for measuring that bore. Just like in my imperial side, I'm going to set this master gauge up. The biggest difference is this one reads on a metric scale as opposed to an imperial scale. One other thing I'd like to kind of note, looking at the face of the gauge, again, we always need to pay attention to the scale that we're going to be reading at. In this case, it's 0.01 millimeters per indentation or per section or line segment on this gauge. You don't need to use a master like this. You can set these dial bore gauges up using just an outside micrometer of the range for which you're going to set your dimension. So in this instance, I would need a 125 to 150 millimeter outside micrometer for my spec of 130 millimeters. This is a very expensive tool. You don't need this portion, but it is nice to have and very easy to set up with practice and with continued use to make measuring bores a much easier and much simpler task. So this dial bore gauge uses set standards within 25 millimeter increments. You see here I have a 100 millimeter standard. This one will be my 125 millimeter standard, where this nice long one will be my 50 millimeter standard. Now again, if I was to slot that in, what I'm actually measuring is the space for my dial bore gauge to measure inside of. The actual tool itself, or the gauge point, won't be 50 millimeters in length. That's much longer than 50 millimeters. If you notice, within these gauges, they go in 25 millimeter increments, starting at 50, going to 75, then to 100 millimeter, and then to 125 millimeter. For my 130 millimeter spec, I need the lowest and closest within 25 millimeters of that number. So I'm going to grab me this 125 millimeter standard, slot that into place. Now this portion here is going to set in between those 25 millimeter gaps. So this essentially reads just like a 0 to 25 millimeter outside micrometer. So let's zoom in. I'll show you some of the increments on this and it'll make hopefully a little bit more sense. Okay, so looking at this anvil portion here, you can see I've got some numbers or some lines on the top row here. And then I've got some numbers or lines, pardon me, on the bottom row here. This top row is going to represent whole millimeter values beyond whatever I've set this master to. So this one I've set to 125. This 0 would be 125. The next line, 126, 127, 128, 129, 130, etc. This lower portion here is going to represent half of a millimeter increments. So this one would be 125.5, and then 126.5, 127.5, 128.5, 129.5. So it kind of goes from whole to half, whole, half, stepped across that gauge there. If I look at this anvil here, at the 0, I'm going to line up with either the whole millimeter up top here, or if I wind that all the way in, one full revolution, back to the 0, you'll see I'm lining up with the lower increment. So this anvil, this rotary dial, is in increments of half of a millimeter. Now, my value of 130 millimeters, I have 125, so I want to wind that in to get my 5 millimeters. 125 plus 5 gives me my 130. Right there. So I'm half covering that 5. which tells me I'm on that line. I'm not on the line after that 130, pardon me, or the 5 millimeters here. And I'm not before it. I can see I have half the distance towards that one there. That tells me I have 130 millimeters. Now this is a pretty easy one to set. So just for argument's sake, let's put another value up there of 137.76. So right here I'd have 130. One full rotation will give me 130.5 and then 136. I'm on that next whole millimeter increment. Now I said 137, so we'll go out till we're on the 137 right there. And then I said 0.76 millimeters. So I'm at the 137. Another full revolution will get me to the 137.5. Now to get to the 26 additional on top of the 0.5 to make 0.76, I need to rotate this dial approximately halfway through its rotation. You see these large line segments. There's one here that I've rolled it over to. There's one here, one here, one here. Those are going to be my hundredths digit on the millimeter, or 0.01 increments. So that'd be 0.01, 0.02, 0.03, 0.04, 0.05, which is the 5. 0.6, 0.07, 0.08, 0.09, 0.1. Okay, so my tenths value now. And then I can continue counting up 11, 12, 13, 14, 15 until I get to 26. 20, 25, and 26 will be right there. That 0.5 plus the 0.26 will give me that 0.76 decimal points. That's all fine and dandy. You'll notice some little tiny line segments in between my hundredths digits. So these are my hundredths. Those will be my thousandths of a millimeter increments, and they're in increments of 0.002 thousandths of a millimeter. So if I had a third decimal place, we'll use our example of 137.76. We'll tack on a 6 onto there. So 137.766. You'd count up in 0.002 increments. So 0.002, 0.004, 0.006. That's my thousandths degree on a metric scale. Awesome. That would be my setting for 137.766. But that's not my value. I'm going to roll this back to where I want it to be for our demonstration purposes of measuring a bore, all the way back into 130 millimeters. There we go. So we'll set that dial bore gauge up to the master with preload to measure 130 millimeters, a brand new liner on a Series 50, to be able to read on the wear side and the smaller bore size. That will help me to identify if I have any rolled O-rings or corrosion or debris built up on those liners. Now, setting up this dial bore gauge is going to be exactly the same as it was in the imperial section. So I'm going to refer back to that video or just slot that portion of that video into this portion. The one thing I do want to note is that same chart that we're going to reference in our dial bore gauge case. This time we're going to find our dimension in this millimeters chart here. So we have 130 millimeters. That's going to fall between 127 and 137. We follow over and we want the 7 and the 4 for my gauge points here included in this kit, just like with our imperial setting. The 7 is a standard for doing larger bore sizes. Okay, the 7 is shown right there on the little gauge point. Okay, I'm going to wind that 7 all the way into my tool down here. There's my gauge up top. I'm going to wind that 7 all the way in nice and tight. And then I'm going to use my little wrench included in my kit to just snug that up. It doesn't need to be tight, it just has to be snug so that it's not going to back its way out. The second gauge point I needed was my 4. If I take a look at these different gauge points, I can see a little number at the end of them there. There's a 4, there's a 6, and they're different lengths. Okay, we can see the different lengths of those. I want the 4, and I'm going to thread that 4 into that tool, but loosely. And I'm going to thread it most of the way in. And I want that to be set nice and loose. So I have the bits that I need. I'm just going to scooch that case out of the way. So I'm going to slap that tool into place. I do not want to have this pulled back against the base. I want that to be nice and loose, and I can leave my hand here to support it and make sure it doesn't fall out. And what I'm going to do is I'm going to wind that out. And while I wind that out, I'm looking at something on the face of this needle. I'm just going to orient my camera so you can see that and see what I'm looking at. So I'm going to wind that gauge point out towards the master tool. And what I'm looking for is movement on that needle. See, right there, I start to have movement. So I'm now causing that needle to move. I'm going to continue to back that out until I go in one full sweep of that needle. One full revolution of the sweep of that needle, pardon me. I'll know I've done one full sweep when on my lower gauge here, my needle sweep or revolutions counter, I've hit the 1 from the 0. At that point, I'm going to tighten up that jam nut on my gauge point to lock that in place at 1 revolution. Now, what that 1 revolution does or achieves for me is it gives me preload and allows the tool to read on both the positive and the negative sides. So what does that mean? On the positive side of this scale here, we see a little plus next to the 0. When I'm taking my measurement, if my needle swings back on that plus side, I have a larger dimension. I'm going to add however many ticks worth of wear to the value I set this gauge to, which is if I swing back when I'm equal and plane inside that bore, and if it bounces back on the negative side, that's telling me I have a smaller dimension. Now, because I set this to the smallest dimension of a new liner, if I get smaller than that, well, I've got a potential problem. What is that problem? It could be a number of things. I could have had those O-rings roll and distort that measurement. Maybe I took that measurement with the cylinder liner out of the block, which it needs to be in the block to have that nice rounded, perfectly round cylinder. Maybe I have some material. Maybe there's some oil. Maybe there's some fuel, debris, whatever it is on the inside of that liner material. That's why I like to go to the smaller range of that, or smaller end of that range, because that lets me know if there's something going on. Once I have that locked, I then can zero my tool. Okay, I'll lock that in place. I'm going to take my tool out of the base and stick it back in. When I stick it back in, it should read again on the 0, just like this. If I take this tool out, I'm going to notice that I'm not going to necessarily read at the 0. So I'm out of the master now. I'm not reading 0, but that's okay. So let's take this gauge over to the block and we'll do some measurements. Okay, so I'm measuring the same block. Now I'm putting it in at an exaggerated angle into that liner within ring travel. I'm measuring my top portion of my liner installed to the block, and I'm going to pull it through its stroke. And I tried to get a better angle on the gauge itself so you can watch what's happening. As I pull it through that stroke, you'll see it bounce back at a certain point. Now, depending if that's on the positive or negative side, I'm going to count up the number of ticks away from 0, and I'm going to add that to whatever my dimension is. I've got 7 ticks in this case. Okay, so 7 hundredths of a millimeter, 0.07, if we look at that scale right on this dial. Each tick is 0.01 millimeters. Sorry, I'm kind of going out of focus here. Each of those ticks represents 0.01. I have 7 ticks. So I'm going to add, because it was on the plus side, that 0.07 millimeters to my base measurement of 130 millimeters as drawn on the board. We're going to add that value, that 0.07 millimeters, to that 130 millimeters. That'll give us the size of that bore and the amount of wear that it has. So my total measurement will be 130.07, which is a little bit bigger than my maximum specification. So that liner is a little bit worn. And if I was doing an overhaul on this engine, I would look to replace those liners. Again, if you find these helpful, please like, please subscribe, please share, comment. Let me know if there's anything that you'd like to see me do. I do this for a learning resource for heavy duty technicians in training. Thank you and have a great afternoon.